Right. Without any further ado, I would like to again thank Stella and Saya for making this happen and enriching the performance community on the internet. And this talk I have given before in a different conference, to be honest. I changed it to slightly since the last time. However, I find it still valuable since I get a very good feedback on it on the conference. So I decided to give it once again in this meetup. And the use community as well. Well, I'm going to talk about building a fast website for every single visitor. I'm going to start with just an introduction. Why the web in itself, the web user is so special, so challenging, because some special conditions for them. The first one, you don't know in which screen size they are going to browse your application. You don't know what internet connection they're going to use. You don't know the browser version or browser type that they are going to use, and even the specs of their devices. It will be different. All these stuff are going to be different from a user to a user. It's not something like you can just build once and it runs everywhere in the same way. And also, there's one thing that the user is doing. You never know how the user is going to browse your application. What is their posture, right? On the other hand, we're not sharing much with the user. We developers are privileged. We're using a cutting edge devices with the latest best memory, best processor. We have the best internet on the planet, right? And we are using usually the latest version of all the browsers. However, only one thing that we're sharing with the end user, which is the posture. We are almost sitting like that if you sit for long times. Cool. So we are in the process of building a fast website for every single visitor. And by fast, I don't mean the speed of the website only. It means the accessibility. We are building a website that is accessible to everyone, whatever the condition is. It is more accessible website for every single visitor. So allow me real quick to introduce myself. My name is Medhat Dawoud. I am a senior software engineer in a company called Miro. I'm also a Google developer expert in web technologies, web performance. And if you like what you see today, feel free to follow me on this handle or find Blue Sky and other links on my website and even performance articles on Metadata. So let's dive in. Performance depends usually on the user perception. So if you are on you are walking and see one on a skateboard, you'll find that the people in a skateboard are fast. Skateboards see one cycling, oh, this is fast. And cycler might see that one in a car is fast and one can see someone on a Ferrari fast. So imagine about perception, where you are and where the other person is. From right to left, you'll find, okay, this is faster. But if you are in anything on the left and you find someone on the right, you'll find it's slower. But what if you are on a motorcycle? This is faster or slower. You'll think as it depends where you are. Things come on the left seems to be faster, and things on the right seems to be slower. I mean, on the right would think that it's on a motorcycle and vice versa. So how can we measure performance to see it's fast or slow? We have two things: lab testing or field testing, also known that as ROM testing. And this is the one that I'm interested in. With ROM testing or a real user in monitoring, you will get a lot of good information that you can utilize in order to know which part of the performance exactly that you would like to invest more. So for this one, you get the core vitals, you get some information. Of course, FID, this is an old one. It's not FID anymore. We're looking at other things, but you get some information about the users. Also, you get the distribution of devices, who is using mobile, who's using desktop and tablet, and so on. So you know exactly which user is being affected badly by your changes in your website. So you know where to invest, not to invest. For example, in this case, everything for desktop users. However, the people who are suffering could be the people who are using tablets. So you need to invest more on a tablet. Also, you get the connection distribution. These all screenshots are coming from Chrome user experience report, and you have plenty of options on the internet that you can use to find out this information. you see that still some people are using 3G, and I'm going to come into that in a bit. So we're learning that no one size fits all. You need to build things that are working for different people differently. It can be just one build and boom, everyone is happy. So you need to pick a target. Would you like to build an application with a cutting edge technologies, which makes you happy as a developer? So you can think about it as you're using the latest version. So you're happy with these versions and you're happy with developing it. However, you are giving a poor experience for people with low-end devices. That's one direction. Or the other target is to build it with the guaranteed conditions, which means that people with low-end devices, high-end devices, unfortunately would be working for them. But the people with high-end devices would like to have some fancy UI and stuff. So it gives you more accessibility, but poor user experience. You have to decide one. This one is so bad because the people with high-end device wouldn't be happy with a poor UI, and this one as well is so bad. We would like to have something in the middle. So we need something that is adapting to the user condition. We need to build something that gives you the best accessibility and in the same time, the best user experience for every single visitor. It is something called progressive enhancement if you are building the core functionality and building on top of it, or if you are building the cutting edge technology, everything, and you are degrading graceful validation for some features to find out how to support users with lower end devices. That's simply it. So what are user-related factors that we need to follow or focus on today? I'm going to pick up some of these cases and let's think together how we would like to fix it for our users in case they are suffering from it. We have screen sizes, browsers, devices, internet connection, and sitting position. This one, obviously, I'm not going to talk about, I'm going to fix, but these four, we're going to get one by one and see what are the options that we have so we can make the website feels faster for our users with different conditions. So screen sizes. Screen sizes is maybe the oldest version of adapting to the user, which is responsive design. So the advice is to build your components as if they are responsive like water. So water, if you put in anything, it takes the shape of this thing. So you need to build the components like water. And some people might think build them like cats. Cats are water as well. This is a very interesting subreddit, by the way. It's called A Cat is Liquid. It's really hilarious. So check it out. But I'm interested more to talk about images because images are like 60 to 70% of the web page's total size. So if you're building components to be like liquid, this means that you don't know even the component itself, where it will fit. Would it be in the full size, small size? Would it be in a big screen, smaller screen? And for that, if you have this image, instead of building it with the normal image tag that we are using, you will find that this is 500 kilobytes. It's okay because you need more data on a desktop. But on a tablet, it will be slightly bad because maybe the tablet is smaller size, so you would like to have slightly smaller image. However, you are still shipping 500 kilobytes. And in a mobile, in a very small device, you are still selling the 500 kilobytes. However, you don't need that much details. Instead of that, you can use something like responsive images, which is giving a source set and sizes. Based on the size of the screen, you're serving a different version of the same image. For this one, it would be 500 kilobytes. This one could be like 100 kilobytes, and a small device, you need to save more data, would be like 36 kilobytes or something. And lucky enough, this is almost supported everywhere. Safari even is partially supporting it, so you can just use it today. This way, you can serve images responsibly without any problem and serve it differently for people with different device sizes. And you can have responsive images out of the box, actually, if you're using any of the Meta frameworks out there. There's always like an image component that you can use, and this image component is being supported with collaboration for a team in Google called Aurora. And this team is helping Next.js and others and help this image component to come out in this way, source set, and gives you different versions based on the screen sizes, as you can see. Not only Next, with Astro, with Gatsby, with all other things, however you are using, you will find this image component. So image component is not only like a different custom component that these native frameworks are giving, they come with some benefits in performance. So try to use them from now on. If you're using something that doesn't provide that, you can use Sharp or something like ImageMagick. And for example, Remix and Readboard, they are not coming out of the box with image component, but you can build it like that. Read the file and serve it and resize it on demand. If you would like to have something ready use, you can use something like Cloudinary or maybe Vercel. Both of them can provide you with these features. So now we can mitigate a little bit the problem with screen sizes and serve the image exactly the size the user is requesting. Let's move on to another problem, browser support. We have different browsers out there and they are out for a reason and different for a reason for the support. What causes a feature to be unsupported in a browser? Just as a refresher, we have two things. First one is rendering engines, and you will find that these three, for example, are Chromium-based, so it comes with Blink, and Firefox is running Gecko, and WebKit is running on Safari. So it's not supported everywhere at the same time. Maybe we have three of them, or the major browsers. Most of them are being supported the same feature more quickly because they're Chromium-based, and others come and follow later. Also, we have JavaScript engines. We have these three are using V8, and we have Safari is using SpiderMonkey, and Nitro or Nitro is being the engine for Safari. This way, actually, you are facing a problem of having one feature support in Chromium, and you cannot just guarantee that it works everywhere. But at least you can serve it to most of them. Why we're talking on Chromium-based, basically, because of this chart. It shows us that the majority of the internet are using Chrome or Chromium-based if we count all of the Chromium-based browsers. This means that if you are serving some feature with a progressive enhancement for a Chromium-based browser, you are supporting the majority of your users. So it's worth this time that you are going to spend. So how can we determine if a feature is now supported? Simply, we used to do that with can I use in the bottom, as you can see, or with MVN as well. And you will find this image everywhere, this check mark. And this means that if it's green, it's available. If it's blue, it's newly available. And if it has this orange axis, means it's not on the baseline, means that it's not supported in all major browsers. But if it is newly available or available, this is so safe. If it's not supported everywhere, you can serve it for the majority, which is Chromium-based in most cases. So as an example, here you can use some API that comes out of the box. For example, this window that navigator to share, not sure if you know it, but you can use it. This will give you the ability to share anything out of the box. Just use the share information coming in your devices. I use this in my website, and if you share something, you use it without shipping any polyfills for sharing, and you can serve it as if it is progressive enhancement. As you can see, it is supported only on Chrome, Edge, Safari. Safari, that's strange. Firefox, the only one is not supporting it yet. And as you can see, you can check if share is in window navigator. You can serve it like that. Else, you can just use a third party. Instead of you used to serve third parties everywhere. So you can this way serve a faster website without serving or without shipping more data for the people who are using the latest browser. For the people who are using browsers, now you can serve them the old way, third-party library. Images, again, yes, images are big assets, so we need to make sure that it is served well. I would encourage you to use sources for different types of pictures. As you can see here, we have three different versions. Instead of doing the image, you can just serve different sources with different extensions. We have WebP. This is pretty much supported everywhere. Avif as well is being supported everywhere since last year. And GXL is not yet supported. And funny enough, it is supported in Safari, but it is coming up in different browsers, and it has a very good compression rate. And you can see this is GXL, this is JPEG XL, I would say. Safari has supported earlier than everyone else, which is good, and others are coming later. So you can serve GXL only for the people who are using Safari, for example, in this case, and maybe uh, Avif for other people. And for the browsers that are not supporting Avif, I'm not sure if there's any, we can support WebP. And in the end, you can fall back to JPEG. And here's a clear example. These three images, one is JPEG, WebP, and Avif. And you will find that Avif, for example, is half the size of the JPEG, and you can't notice with your bare eyes any difference. This is important. You can also use browser lists, and this is helping you with having check for browser support in different things, double and next and everything else out of the box. You can see how much you are supporting with your build tool like Bubble or Webpack. And anything that you are going to deprecate, you can just go to browser list and change your target to a different thing, and it will help out. I think this is just a refresher. Everyone almost is using that. Let's move on to a different thing. I hope we mitigate a little bit the browser problem. Moving to the device, CPU, and RAM. There is some stuff coming out of the box that you can use. And we all know this, famous comment. Chrome used to eat a lot of your RAM. So you will feel that, okay, Chrome is slowing us down, and you used to blame Chrome. And if your manager say that why the browser is not served very well, you said, oh, Chrome is eating all the memory. However, Chrome a couple of years ago brings this to the table. When you hover over the tab, you'll find that the amount of memory used by this exact tab, and this becomes your problem. Every developer starts thinking, okay, we used to blame Chrome, now it's our problem. It's our tab is taking too much of the memory. Now it's our job to fix it. For that comes some APIs like device memory, and it is experimental still, but this gives you an approximate number of gigabytes for each device. This means that you can just serve a different action or a different UI for the user based on how strong their RAM is, how much you can just cache or how much you can utilize their memory. So for example, here in this example, we are serving the heavy feature in case if it's a strong, and you can decide strong is more than 2 gigabytes and weak if it's less than that. And this way you can serve a different experience. However, it's like graceful degradation for your feature, but core feature can be served in any way. This one, as it is still experimental, it's been supported with Chrome-based browsers, but Safari and Firefox not yet supporting it, but you can try it out today as a progressive enhancement or graceful degradation. Another one is about the hardware concurrency. You can ask for this one as well. Window Navigator hardware concurrency gives you an approximate number of the cores that you have in the user's computer. So based on that, if you're serving like a 3D model or something, you can decide whether to load it or not to load it based on how strong their device is. Same way, you can check how many cores you have, and based on that, you can enable high performance mode or enable low performance mode, and so on. I know this is not coming out of the box or something that you will think about it as you are building a new feature, but you find it out, as I said, by the RAM information. You find out that it is bad for people, for example, using low-end devices. All right, I'm going to add these extra checks so I can serve a better experience for them. And lucky enough, this one is being supported in major browsers, so you can go ahead and use it today. If you are working in a website that is utilizing a lot of the user processor and needs more cores, maybe running the different web services or something, so you can see how many cores that you can run concurrently. This is useful as well for some specific cases. Moving on to one of the most interesting ones, internet connection. People are changing their place and changing their internet speed from place to place, and you will never guarantee that they are always in 3G, 4G, or 2G or 1G. Imagine that this is happening even for every one of us if you are getting into a cafe or maybe the internet in the airport. They are not always stable. So if you join them, it is going to be maybe degraded a little bit. And this chart is showing us that eventually in 2030, 5G will be dominant. But we are still in 2025, which means that we have a lot of people are still running in 3G and 2G even. Yes, don't be surprised. We have around like 20% of the population of the internet, and this is a lot, are still serving in 2G and 3G. And maybe 4G is still dominant and 5G is still rising, but 2G and 3G are the people that we need to care about and serve them still a reasonable enough fast accessible website. And you might have seen that before. If you open YouTube on a poor connection, sometimes, as I said, an airport or something, you'll find that the YouTube has degraded the speed automatically to be 240p or something. And this happens to me. I think it happens to you as well. And this, in my case, I am just throttling it. But this is happening out of the box if we detected that you have a bad connection. And this means that they are serving still the core functionality, which is watching a movie or a video, but at the same time, you get maybe a poorer quality of it with no problem. Also, if you're using a meta frameworks like Remix or maybe Redwood or Next, we can use something like Form. What is so good about the Form component is that this Form component is serving you with some server-side renders form, and it falls back as well to the normal HTML form, which means that some people might be disabling JavaScript even, or JavaScript takes time until it comes back and rehydrates your page. If you use this form that comes out of the box, this means that regardless of the internet connection of your user, they are able to submit some forms without waiting for long time periods. This is important as well, and a good advice if you're using this meta frameworks. Finally, the network information API. This one is experimental and most probably is going to be deprecated, but I'm going to share it with you as well. You can see when you navigate to the connection, it comes with some handy information like effective type, which is in this case 4G. It can be different as well. You can ask for that network type, and based on that, you can serve different things. For example, you can serve a video or a high quality image in case they are 4G or above. And otherwise, you can just low quality images or maybe text in some cases. This is a good example as well that was shared by Google before. 1 mega, 1 meg in case of a good internet. So you can serve a video. And in 2G, 3G, you can serve only like a 30 kilobyte image, which is useful as well to serve a decent enough experience for both users with different conditions. This is being supported on only Chromium-based browsers. And as I said, most probably they are going to be deprecating it. And this is a little bit funny because you will find that Firefox supported in 30.1, and then they won't support again for some security reasons. And it has some security issues indeed. I'm not going to talk about it now, but it's interesting. I encourage you to go ahead and read about this case from Firefox. Also, for supporting that out of the box for the React users, you will find that there's something called React Adaptive Hooks that just takes everything comes from these APIs and serve you as hooks. If you are using some like Vue.js or something, there is something called the Vue Adaptive Hooks as well, and so on. I find out that there is also an official proposal for a different version of this one for network information. You can find something like that on the internet. I think I put it in the resources as well. They are going to check not for 4G or 3G or something, because actually these are very static information that doesn't indicate how fast or slow this 3G or 4G at the moment. However, this is more interesting because it gives you an idea if this network that you're using right now or the user is using right now is metered or not. If it's metered, means that it is counting the number of gigabytes or megabytes that you are using. This means that they have a very poor connection, or at least they have limited connection that might be depleted soon. So this way you can serve a different way, different version of your AV features. And you can ask for sustained speed and on change. This is still unofficial, but I need to share with you as well in case you are interested. Read more about it. It's still unofficial. So as a recap, we thought about screen sizes and how we serve responsive images easily in different conditions. We thought about browser support and even browser versions and different features, devices, CPU and RAM, and also internet connection. Maybe we didn't serve this problem, but this I will leave it up to you. There is some resources here. Thank you very much for listening up, and back to you.